Okay, now the male cats are joined by 80 female Persian cats. The female cats are drawn from a population whose weights are normally distributed with a mean 4.5 kilograms, let me underline that, and a standard deviation of 0.45 kilograms. 10 female cats are chosen at random. Find the probability that exactly one weighs over 4.62 kilograms. Right, this is a bit of a confusing question because this is a normal distribution, but this is a binomial distribution. I know it's a binomial distribution, but there's three kind of giveaways. One is this 10, when you see 10 female cats, that's our number of trials. The probability that exactly one, so again, that's the second kind of giveaway, exactly one is binomial PDF, and then weighs over 4.62 kilograms, so that's your either they're over 4.62 kilograms or they're under 4.62 kilograms. So I'm going to start by bringing in a letter X, and I'll say X is, well, sorry, I'll start with the normal distribution because I need to find the probability. So I'll say X is a normal distribution with a mean of 4.5 and a variance of 0.45 squared. Just be careful, guys, that's the standard deviation. So the probability that X is greater than 4.62, this I need to do with my calculator. So it's menu, probability distributions, normal CDF, lower bound is 4.62, upper bound is some big number, let's do 9999999, mean 4.5, standard deviation 0.45, press enter. 0.394863, 0.394863, right? I'll leave that like this, and then I'll bring in another variable, y, and I'll say y is a binomial distribution. Now n is 10, it's the number of trials, or number of cats in this case, and the probability is this 0.394863. And we want to find the probability that y is exactly 1, because that's what he says, exactly 1. So, like I said already, this is a binomial PDF. If it was greater than 1, it would be CDF, but it's exactly equal to 1. So the number of trials is 10. The probability is 0.394863. The X value is 1. And I get 0.042966. 0.042966. Yes, 0.042966. Okay. So, does that make sense kind of in context, guys? Well, yeah. Out of 10 cats, that exactly one of them would be over this. I would expect that to be a low probability, so that seems fine. Let's just make it 3 significant figures here. 0.0429, that would actually be 430, but whatever. Okay, part II. Let n be the number of cats weighing over 4.62 kilograms. Find the variance of n, right? So this is still related to the 10 female cats, because like this is part D and this is part D, so it's still related to the 10 cats, not the 80 cats, the 10 cats. So find the variance. So we're dealing with this binomial distribution here, and the variance for a binomial distribution is in the formula booklet. It's NP times 1 minus P, where N is 10 and P is this 0.394863 times 1 minus 0.394863. Take out our calculator and we'll do 10 times 0.394863 times 1 minus 0.394863, and I get 2.38946. 2.38946. And there we go, 3 significant figures, 2.39. And that's the variance. Okay, that's part D.